Well, one of the things that happened with automating as much equipment as we did was the sheer volume of alarms that our control center was having to manage. And so the magnitude of alarms is in the neighborhood of about 100,000. And so for those of you people who've ever had the opportunity to sit in a control room and have a flood of alarms come in at 15,000 or 30,000 at a time, you can appreciate knowing which alarm was the first alarm that came in, which alarm is the important alarm that came in. So LES adopted a process, an ISA standard called Documentation and Rationalization, or the DNR process. And I'm sure a lot of you people in the refinery industry are probably going through some alarm management process right now. Well, this worked very well for us for several reasons. One, we had a high attrition rate, we had new equipment, we had a turnover that we're doing with the manufacturers, and we took the opportunity to grab 60 of the best minds that we could find with both internally in LESCA, the manufacturers, the vendors, reps, collect all that data and gather it into this DNR database. And I don't know if it's clear if I'm articulating how important that is, but what this process tells you is your response time to an alarm. Some alarms are seconds, some of them are minutes, and in the DNR process is not to exceed 30 minutes. Well, one of the things that rolled out of that was alarms clearly were non-operational alarms. They were engineering related data, they were vibration data, they were RTD data, pressure transmitter data, and so they either fell in an engineering bucket or a maintenance bucket. Well, the process worked so well for us that we adopted it to use it in our PI system. We use the same methodology, the DNR process, and how to prioritize an alarm, how to weight an alarm, and how to utilize that alarm. And so down here at the bottom, I've had to take the data points out, but you can see where it says tag justification. So every PI tag internally in LESCA right now, we give it a justification. We also found that we need to assign ownership. Who owns it? Does it belong to the environmental department? Are they using it for NOx calculations? Are they keeping us within our air quality permits? But the more and more calculations that we developed, we realized then that we needed to then manage the calculations and the dependency tags for them calculations. So we use the same DNR process, and you can see the second one to the bottom there. It says tag dependency. So if we have 10, 20, or however tags we have to support a single calculation, we now manage that in this DNR process and database so that a year from now, 3 years from now, when people are saying, hey, we're changing out this equipment here, do we need to maintain this PI data point? We can quickly reference it and see, yes, it is dependent on a calculation for something bigger than what it seems. Hopefully that makes sense. So each one of these systems sort of rolls up into the alarm viewer, but each one of the four I just showed you is also completely independent and can be reviewed anywhere through the entire organization, at a vice president level down to the technician level in our company. So here's what we did. These 100,000 plus alarms that we have with our new equipment, the DNR process prioritized every single one of them. 15,000 of them belong to maintenance and 6,000 of them belong to engineering. And so we bring these alarms into the alarm management system where that they can be evaluated. I don't know if you can read the second column over there, but the DNR process has already given them a priority. If they've had a priority, then the reaction time, their planning, scheduling time, the maintenance required action, engineering required action has already been predetermined. So on the left-hand side of this thing, you'll see a search criteria. You'll see the tag filter and the tag sort here. So we have the ability to see any alarm at any one facility. We have the ability to see our condition-based monitoring ones that we've done. So any deviation based on pressure transmitters, RTDs, radar devices, whatever they are, We've built the condition-based monitoring in, our SCADA system tags in, we've built in our predictives, rate of rise, all of that comes into one central viewer. Well, that was a great start for us, but the next thing that we did was realizing the more dependent we become on this data, the more we realized we had to ensure that the systems delivering this data was giving us that information. So we started taking the data out of MCN, for those of you who are using MCN, and all of our watchdog timers measuring, you know, are we having connectivity between our nodes, our maintenance servers, all that data. How do you ensure that that data is getting down there? All of them values roll up into here, as well as the data points for our efficiency-based models.